Okay, so we're going to look at some graphing some more trig functions. In this video, we're going to focus on tangent cotangent, which, there's not as much to show as like the sine, cosine, and the secant, cosecant. And the other thing I want to remind you of is that the fundamental period of tangent and cotangent is only pi, not 2 pi. So in all of the other examples so far, we've had to get the new period, we've done 2 pi over b, the frequency. Now, because the period of tangent and cotangent is only pi, we need to make sure that we are only dividing pi by b. And for example, this frequency of 4. So my new period here, the new period will be pi divided by 4, or 4 pi. Or just pi over 4, sorry. So when we graph this, again, I always like to put the labels afterwards. So think about, what is the tangent image? Tangent image is a lot like the cube, y equals x cubed. So your graph is going to go right through the origin like that. But remember, there's a vertical asymptote here and here. Now, normally, that's at pi over 2 and at negative pi over 2, because there's our fundamental period, that fundamental length of pi. If my new period is now pi over 4, then I have to divide that into fourths, right? So pi, like that interval is now pi fourths. So that means if I divide a pi by 4, then these would each get divided by 4 as well, or they become negative pi eighths to positive pi eighths. And if you think about that distance of negative pi eighths to positive pi eighths, then that is a distance of pi over 4. That looks like a 9, so let's fix that to make a pi over 4. Okay, excellent. So then that's where that asymptote would be. Now, remember, we want 2 fundamental wavelengths here. So we would come up this asymptote and stop there. And then we could have one here and continue on up. Or you can just continue this and make another asymptote here and continue this down here to make another asymptote there as well. Up to you. Now, think about, how are you counting this? So this region here, right, from 0 to pi eighths, and then you have another region from 0 to pi eighths. So that's going to help me get 2 of the pi eighths, or pi fourths, is that label right there. I guess we'll go blue, sure. So I know that this intercept right here is pi fourths. And again, thinking from intercept to intercept, it has to be, again, the same fundamental 1 period, pi fourths. It shouldn't matter, right? Like, it shouldn't matter where you take this interval. Like, it should be the same, wherever, like, from one part of the graph, like let's say asymptote to asymptote to the other. So that's how I know that that's going to be, also pi over 4. And then, so if I add pi over 8 to that distance, or make that a total of pi over 4. So this distance here, right there, that needs to be pi over 4 as well. So then that would make that asymptote 3 pi over 8. I'm going to go to the pen. 3 pi over 8 is that asymptote. By symmetry, then, because it's an odd function, this is negative pi over 4, and then this could be negative 3 pi over 8. Okay. Now, even if you put a coefficient in front, the stretch of an amplitude doesn't really make sense for tangent, right? Because tangent, there is no upper, like, peak or lowest trough, so that's it. It would be more stretched if, like to use that word, but it's all relative to how you drew that. So really, we just focus on the new period, not an amplitude. Okay. Again, that awkward coefficient pi eighths, but actually nice things happen. Remember, now for tangent and cotangent, it's the new period is pi divided by b, right? Pi is the new normal period for tangent, cotangent. So you get pi divided by pi eighths. And then that flips up, pi's cancel. So we really get a new period of 8. So when I draw my cotangent function, I'm going to draw in that label last. But if I think about what does that look like, there's my y, there's my x. So remember, that particular function is a decreasing function, and the asymptote's at 0, and at the end of the full period. And I could draw one over here too. Might as well do them both at the same time because it repeats itself. And so my fundamental period must be equal to 8. So this distance here must be now equal to 8. And so then that's 0 and that's 8. That's really nice. And then halfway would be 4. Then there's the other intercept of 4. Here's negative 8, right? As an vertical asymptote, x equals. And again, like the vertical stretch of it, if there were a coefficient here, we would draw that relative to what we're drawing, but it really, I'm focusing just on finding that new period in labeling. Okay. Now, the next example is, I am putting a coefficient here, but more or less it's a negative to realize it's going to be a reflection. The 3x is going to change our period, and then plus 3 is going to shift everything up 3 units. So our line of equilibrium, instead of being the x-axis, is going to serve as like y equals 3. Let me get that. There we go. So what I'm going to do is I'm going to call that y. Call that x. And I'm just going to even draw in like 1, 2, 3. I'm going to draw in that pseudo the pseudo x-axis. It's going to be my line of equilibrium. So it's not an asymptote, it's just that line of equilibrium. And then when I draw my tangent graph, again, I can think about, okay, so normally it goes through the origin, but now that's going to get pushed up there 3 units, so it's going to come up here, and I do one of these things. Right? And I draw my vertical asymptote, and I draw my vertical asymptote, right? And again, because of the coefficient of that 3, I would think pi divided by b is the new period, so pi thirds. So this distance here has to be pi thirds. Well, they used to be like a negative pi over 2 to positive pi over 2. So if you divide those by 3 as well, you would get negative pi over 6 to positive pi over 6. Because again, that distance is equal to 2 pi over 6, or pi thirds. And then I would, I could continue that image looking something like that. But we want to be very cautious, and some of you have already caught this, is that we still have the negative. And so that negative is going to be a reflection over, since we did our shift already, it's going to be a reflection over the new x-axis. Or if we would have done the reflection first and then push it up 3. So I need to take my image, and I guess I'll use red, and the true graph is just going to be this darker red one, because that's the reflection over the new x-axis. So, and then there would have been a vertical asymptote there, just like that. So the asymptotes don't change, right? They stay the same. We just get the actual image it certainly looks like the cotangent image, and it is the cotangent image. It's just not in the right location, right? It's shifted over a bit. So again, maybe if you wanted to see that again, what does that look like without maybe the like all of the extra steps there? If I just had the graph, so there's the x-axis, so the y-axis, there's the x-axis, we're up 3 units, so there's my pseudo y-axis. I'm going to go ahead and already do the reflection. So I have a vertical asymptote here, I have a vertical asymptote here, and then my graph would now be a decreasing function like that. There's your quote-unquote 0. Your fundamental length here between any 2 asymptotes would be pi thirds. So this is a pi over 6 as a negative, and this is pi over 6 as a positive. Okay, so hopefully that's good and that makes sense on that. And that, like I said, that would be kind of your basic tangent cotangent graphs. You don't need as much. And so far, obviously, the only thing we haven't done now is just shifted things left and right, which we'll look at next.